Okay, let's finish up this discussion of functions. We're going to look at how do you find the domain when the function is written as a formula or an equation, whatever you want to call it. It's pretty easy to find the domain when it's written as ordered pairs or a graph. But what if you had this formula like this? How do we find the domain? Well, before I actually do that problem, let me say this. If the function is written as a formula, there's two things you have to remember. You never want a number over 0. That would be an undefined on your calculator. Okay? And there's another time you get an error message on your calculator, and that's when you get an imaginary number. These are the two things we don't want to happen. Okay? We don't want a 0 in the bottom of a fraction, and we don't want a negative number under the square root. We defined imaginary numbers at the beginning of the semester, so we could spend the rest of the semester saying, but we only want real numbers, we don't want imaginary numbers. So we want to avoid zeros in the bottom of fractions and negative numbers under the square root. Those are the two things we want to avoid. So on that problem number 14, we're given the function f of x equals 7 over x plus 13. When it asks what's the domain, it's asking you what numbers can you plug in for x. What numbers can you plug in for x and get a real number back for y? If you were going to punch in your calculator, could you plug a 1 in for x? Well, sure. 7 over 14, your calculator would give you, what, a 0.5? If I plugged a 1 in, I'm just choosing 1 at random. Okay? But what number can't you plug in? There's one number that we can't have. Well, we can't have a 0 in the bottom of the fraction. See if y'all recall doing this before. If you have a fraction, you say, okay, the denominator can't be 0. Isolate the x, and what would we get? X can't be what? Negative 13? That means x could be anything else except negative 13. Back in the olden days, when they asked, what is the domain? The answer would be, okay, x could be any real number except negative 13, but that's not how we write it now. Now everything's interval notation. If you look at those answer choices here on this one, just interval notation. So how do we write all numbers except negative 13 in interval notation? Well, if you have a fraction, all you're doing is finding that denominator cut point. If you look at that little leaflet that I gave you back when we did cut points, the denominator cut points can also be called domain cut points. X can't be negative 13. That means we want to exclude negative 13. What means exclude? Open or close circle? What is exclude? It's open. Okay? Open means exclude. It can be anything else. Okay, negative infinity to negative 13 union negative 13 to infinity. This right here is just interval notation, or a shorthand way of writing. Oh, wait, I'm sorry about that. Oh, let me move this also. All numbers except negative 13. Back in the olden days when we were in college, we, meaning my brother and I, not you and I, we weren't in college together. But the teachers would say, write it out in words. Put as much as you can in words, because most people pick up some algebra. They're not going to understand what that's happening. If my 92-year-old mother looked at that, she wouldn't know that this means all numbers except negative 13. Now, if it had been written out in words, she could read it. Oh, all numbers except negative 13. It's probably to the detriment of math in the United States that everything, starting around 1990, everything started going into this symbolism. Write it symbolically rather than out in words. Well, that's bad because it just intimidates people that don't know that don't know algebra or know little algebra. How many people looking at this would know that means every number except negative 13? Most people don't know that. Okay? But that's the answer. Let me get up back over here. Oh, wait. I was about to click A, but no, it isn't. It's not A. A would be, let's see, trace it on the number line. Negative infinity to negative 13. Negative 13 to 0. 0 to infinity. Those parentheses mean not including. So answer A would be all numbers except negative 13 and 0. There's no reason you can't put a 0 in for x. You'd have a decimal number if you put 7 divided by 13 in your calculator. So it is C. Now answer choice D is the fancy way of writing all numbers except what? For D, all numbers except, that would be 0. C is all numbers except negative 13. And did y'all see how why I drew the number line here? So I could see, okay, it's negative infinity to negative 13, negative 13 to infinity. I'm mentioning this because some of these won't be multiple choice. Okay? So the first rule that we have for finding domains, you cannot have a 0 in the bottom of a fraction. So if you have a fraction, just say denominator can't be 0. Do the same thing you did for denominator cut points on the cut point method. Now, problem number 15. You write it down. Looks pretty difficult, doesn't it? F of x equals x squared minus 9x plus 8. Well, at least it's multiple choice. Well, there's two things we want to avoid. We don't want to denominate a 0 in the bottom of a fraction, and we don't want a negative under a square root. If there's no fractions and no square roots, like number 15, there's no fraction and no square roots. So, if there are no fractions and no square roots, the denominator is just all real numbers, which we're not going to write out in words because heaven forbid someone might be able to understand what we're saying. So if you see a function, if it asks you what's the domain, and if there's no fractions and no square roots in it, you just say all real numbers, negative infinity comma infinity. That would be that one. Just to make sure you're sort of getting the hang of this note, answer choice A, if you had to write that out in words, it would be from negative infinity to infinity. So all numbers except what? What's answer choice A say? All numbers except negative 8. Answer choice C, from negative infinity to infinity, all numbers except what? 0. Now what about D? Negative infinity to infinity, all numbers except negative 8 and 0. And there will be some eventually where you'll have to write it out like that with the union symbol. Number 16 isn't one of them. Number 16 is another multiple choice one. Let me write it down. F of x equals 1 over x minus 11 plus 6 over x minus 6. Well, if you're going to guess on this one, don't guess the negative infinity to infinity. You guess that if there's no fractions and no square roots. And heck, on this one, there's two fractions. What x value would make this fraction undefined? What would give me a 0 in the bottom of this fraction? Would it be 11? What about the second fraction? What x value would make this one undefined? A 6? So in words, what's the domain? All real numbers except 11 and 6. But we're not going to write it out in words. First, here's my thought process. Denominator can't be 0. Isolate the x can't be 11. Then denominator can't be 0. Isolate the x can't be 6. So in words, if someone asks you, what's the domain? You can say, okay, every number except 6 and 11, or 11 and 6. There, it doesn't matter which number you say first. But with this interval notation, it does matter. If I mean everything except 6 and 11, how would I write that in interval notation? And you might be thinking, well, wait, I can just look and see which one has a 6 and an 11 in the answer. Yeah, you can, but not all of them are multiple choice. We're going to get some in a moment that aren't multiple choice. So it would be parentheses, negative infinity, comma, 6, parentheses. No, because you mean not including, and open circles and parentheses mean not including. If you put a bracket, then you're including the 6 and 11. Well, heck, yeah, you're specifically trying to exclude the 11 and 6. So it should be a parenthesis. And then parentheses 6, comma, 11, parentheses, another union, parentheses, 11, comma, infinity. All of this stuff here is just a fancy way of saying every number except 6 and 11. Which one is it? Okay, answer A is all numbers except 0. That wouldn't be it. It's certainly not B. You would use B if there were no fractions or square roots. And you have fractions here. Is it C? Yeah. D would be all numbers except 11. (17) and 18 are going to have square roots. I'm going to show you the two problems so you can distinguish between them, because I'm going to tell you two different ways of doing these. Well, okay, so here's a square root with a fraction. That's 18. Here's a square root with no fraction. So let me write that down. Problem number 17. We're trying to find the domain of f of x equals the square root of 28 minus 4x. Find the domain. And this is one where you have to type in the answer. Okay. It's not multiple choice. Right? Well, we had said For square roots, we do not want negative numbers under the square root. So, if you have a square root function, and you're trying to find the domain, you're going to turn it into a cut point problem. Take what's under the square root symbol and solve 28 minus 4x is greater than or equal to 0. It's okay to have a 0 under a square root. You can't have a 0 under the bottom of, or in the bottom of a fraction. But for a square root, if I pull up my calculator, what number would give me a 0, would make that 0? Could y'all solve this? Use cut points. Sometimes students say, oh, it's hard using these cut points here because this problem is so much easier than any cut point problem you've done. To solve this using cut points, you just solve 28 minus 4x equals 0. Isolate the x. I think I'll move the 4x to the right. And then do what? Divide by 4. So what number would give me a 0 underneath here? Well, a 7. If I plug a 7 in for x, is my calculator going to give me a... Ooh, let me move this over. If I plug a 7 in for x, that's square root right here. I punch in second square root, 28 minus 4 times 7. Is this going to give me a number or an error? It gives me a number. It's okay to plug a 7 in for x. That's why I'm saying greater than or equal to 0. Now continue with the cut point method. And it seems difficult or maybe not difficult, strange just because there's only one cut point. This is a much easier cut point problem than what y'all have been doing. You take what's under the square root, go greater than or equal to 0, find the solution cut point. Since there's an equal sign, what am I going to put at the 7? Open or close circle? Yeah, close circle. And then test one of these. When I say test it, I'm plugging it into the statement that has the greater than symbol. What do I normally use to test? 0. And 0 would be right here between a negative and a positive. 4 times 0 is 0, so I'd have 28 minus 0 is greater than or equal to 0. Is that true or false? 28 is greater than 0. That's true. There's your domain. This one over here would be false. So the domain is parentheses. The domain is parentheses negative infinity to 7 bracket. Okay. So let me see if I can. Trying to get the whole problem showing on the screen. To find the domain when you have a square root, take what's under the square root symbol and use cut points with greater than or equal to 0. So you solve it with an equal sign, put a closed circle, and test one of the intervals. If you want to test both of them, fine. But when I test, I'm testing the statement that has the greater than or equal to. Okay. Now we'll compare that in a moment. Let me punch this one in. We'll compare it in a moment with, parentheses, negative infinity, comma, 7 bracket. Compare and contrast that one to number 18. Well, 18 is multiple choice. No, that's not the point. The point is, here there's a fraction. On 17, there's not. When there's not a fraction, that's when you do the greater than or equal to. Because it was okay to have a 0 in the bottom of a square root, or under a square root. But what about here? What number would give me a 0 in this bottom? A 9? If I plug a 9 in for x, is it going to take that on my calculator? If I go 1 divided by the square root of 9 minus 9, is it going to give me back a number, or is it going to give me an error? Error. You can't divide by 0. So what am I trying to say? Well, let me write this problem down. 18 f of x equals 1 over the square root of x minus 9. More. Okay, so number 18. If there's a fraction with the square root, you're going to take what's under the square root symbol and just say it has to be greater than 0, not equal to 0. You can look at both of these. If there's no fraction, just a square root, you say greater than or equal. And the only time that greater than or equal becomes significant is down here when you're plotting the cut point. Over here, when I plot the cut point, will I have a closed circle? No. Okay, let's find the cut point. It's pretty easy to find it. You just say x minus 9 equals 0. Move the 9 over. Much easier than anything you did, any homework problems you did with cut points. Draw your number line. And right here, the difference between greater than or equal to and greater than. You're going to put an open circle because there's not an equal sign on there. And test your interval. Which one do you think I'm going to test? I'm going to test 0, which would be the negative infinity to 9. So right here, testing 0. 0 minus 9 is greater than 0. Oh, that's false, isn't it? So what's the domain? That one over there, 9 to infinity. It seems a little strange just because you have there's just one cut point, and it's super easy to find that cut point. Okay, but are y'all following the logic of why? On some of them I said, on this one I say it's greater than or equal to, and all that does is affect the dot. Whereas over here, just greater than. You don't want this to actually equal 0, because if you do, you have 1 over 0. That's one of the things you want to avoid, a number over 0. Okay? Trying to avoid. We also don't want negatives under the square root symbol. That's why over here, if you had plugged a 0 in it for for x, you'd have 1 over 3i. No. Okay? You can't have any imaginary numbers. So, come over here. Oh, I don't have to type this one in. It's multiple choice. Hey, C and D look an awful lot alike. Which one is it? C? It's the one that has the parenthesis, not the bracket. when there's no fraction on the square root. That's when you have a bracket. Okay? And it has to do with that greater than or equal to versus just greater than. Okay? But both of these, it's a pretty easy cut point problem. Don't y'all remember? Y'all had some cut points where there were, I think there was one where there were 4 cut points and so forth. Here, it's real easy to find the cut point. Okay? I'm not going to do this one, but if I look at, let's say, similar question, how would you go about finding the cut point? Could y'all tell me what it's going to be? If I put 15 minus 3x equal to 0, what would that be? Would it be a 5?
Yes.
Okay, what about this one over here? Oh, say best score. On this one, maybe. Well, oh heck, what would the cut point be on this one? A 5. So it's real easy to find those cut points. Okay. Any questions on those two? Those are the two that are tricky in this assignment. Okay, some homework assignments, they're all hard. Here, it's really 17 and 18. Oh, what's that? No, say best score. Well, number 19. Number 19. Are we going to have to do cut points? No. You do the cut points when you have the greater than zeros, the square root ones. On number 19, let me write it down. F of x equals 1 over x squared minus 2x minus 3. I claim that number 19 is very similar to problem 16. So there's 19. Very much like number 16. Okay. Well, denominator can't be 0. These were easy to figure out, the 11 and 6. Here it's not quite so obvious. What do I need to do to make it be much more obvious? If I do this, does that give you a hint what I'm saying you should do on that one? Factor it. If you factor the bottom, we'd have an x and an x. Not a lot of numbers multiply together to give 3. What would y'all use? 1 times 3. Now the second sign is minus, so that would be 1 plus and 1 minus. You don't look at the first sign. Second sign is minus, so a plus and a minus. How should I arrange the plus and minus to get a negative 2x? Plus 1 and minus 3? Is that what I heard? I agree with that. Now is it as easy as number 16? Yeah. Take each one of those. Say it can't be 0. So x plus 1 can't be 0. And x minus 3 can't be 0. So x can't be negative 1. And x can't be what? 3? You don't have to test with this one. This is the one where I just draw the number line to help write the interval notation. We're talking about all numbers except negative 1 and 3. Notice, number 19 is very much like what we did here. Now, how do we tell the difference? Well, these have fractions. How does it differ from 18 and 17? 18 and 17, what? Had square roots. Okay? So number 19, you're back to ones that have fractions. You didn't have to test, but I wrote out the number line because this is one. I don't think this one was multiple choice, is it? Okay, you're going to have to type it in, parentheses, negative infinity, comma, negative 1, parentheses. Union, parentheses, negative 1 to 3, union, 3 to infinity. And what is this, a big old fancy way of saying? Well, every number except negative 1 and positive 3. Okay. Notice I drew the number line just so I could see how to write the interval notation. You don't test unless you're doing one of the square root ones. Okay? When you have the square root ones and you're solving an inequality, that you do the testing. So let me type that in. Parentheses. You see, this is one that's not multiple choice. Parentheses, negative infinity, comma, negative 1, close parentheses, hit the union, parentheses, negative 1, comma, 3, close parentheses, hit the union, parentheses, 3, comma, infinity, close parentheses. Okay. Any questions on that? Hopefully you see how these last three differ. 19 is just a fraction. 18 is the most involved, the one that takes the most thought up here because it has a fraction and a square root. And 17 is just a plain square root. Number 19, I did the same thing on that I did on this one, with one extra step. What was that extra step? I had to factor that denominator. Okay? They're not all as long as those. The last ones here are the longer ones. Any questions over those? Are there any questions on what you should be doing now? Let's see, is it going to pull it up? We are up to functions, and you'll notice if for some reason you're not here on Monday when we do homework assignment 12, my brothers, okay, here are the videos for homework assignment 12. Okay. Now, if you're wondering, well, wait, I want to see what you actually did in class on that day, what I did, then that's when you got to go to YouTube and look at the Spring 2020 playlist. Is that clear? These are the videos that were made in the past. Okay? Of course, oh gosh. If I haven't insulted y'all's intelligence yet, I just did. I'm telling y'all that I haven't posted the stuff that I'm going to record next week yet. I haven't time traveled, got the videos made, and come back in time. No. I'm sorry about that. Y'all must think I'm an idiot. But okay, oh gosh, am I still recording? Okay, let me stop that.